Let's learn a little more about the term photometric light. We're going to activate some street lights in the scene to illuminate this street and make it a convincing evening rendering. But first we need to look at the term photometric. So far, all the lights we've used have been photometric. They are lights that use real-world intensity value. The sun is extremely bright. The direct light emanating from the sun and the sky in the previous rendering has an extremely high intensity value, approximately 80,000 candelas. The important thing to understand is that photometric lights are accurate in real-world situations. Photometric lights are also able to use something called a photometric web, or IES data file, in order to simulate a physical light fixture. These files describe the distribution pattern of the light and provide a way of creating highly realistic lighting setups. This pattern is also dependent on real-world scale. Because of this, it's very important that your scenes are created with real-world scale. A small building should be 20 feet by 20 feet, and a filing cabinet should only be 18 inches by maybe 2 feet. This is important because if things are built to incorrect sizes, the lights won't work properly. Let's take, for example, we have a standard 100 watt light bulb in a room that's only 10 feet by 10 feet by 10 feet. The room will appear very bright and it'll illuminate fairly nicely. However, if we take that same light bulb and place it in a 10,000 foot by 10,000 foot by 10,000 foot room, the light in the center of the room would be a mere pinpoint of light, and the edges of the room would be in complete darkness. This is why building to the proper scale is very important. Now, light falls off using something called the inverse square law. Basically, what that means is the further you get away from the light, the less light that reaches the subject. If we put this in graphic terms, if you're 1 foot away from a light, the brightness value of the light on that surface will be equal to 1. If you're 2 feet away from the light, the brightness value on that surface will be 1/4 of the brightness than it was at 1 foot. And this goes for if you're 3 feet away, the brightness of the light would be 1/9 the brightness that it was at 1 foot. So you can see the further away you get from the light, the less light falls on your subject. Now, it's not important to understand the technical aspects of this, but it is very important to understand that photometric lights are based on the realistic properties of light. This is why you need to use real-world sizes when generating 3ds Max models.